Here we have a free body. Hello. Today, me and Gamira will be presenting the principal impulse momentum problem. This is the fourth problem from the task. Here we have a free body force diagram. The spring force is calculated through the force is equal to negative k times by the x-axis. The gravitational component is calculated through the value for gravity perpendicular to the normal of the incline with no friction considered. Here we have the manual calculations with the given data assumptions using Newton's second law with the derivation and assuming that all is negligible and V2 is equal to V1. From this conclusion, we can say that the object keeps going back to the same place and repeating the same movement, resulting in the principle of inertia. Here we have a snapshot of our Simulink model where the block is faced along the incline, showing that the block will travel back to the spring where the spring actually propels the block up the incline. From our first experiment, we had our parameters set to 10 degrees of an incline with the length of the incline being 1 meter. Here our inertia parameters were set to 1 kilogram and our regular density parameters, and here on the right are our graphs. So this shows the oscillations of the spring compared to when the spring propels the block. Compared to our first experiment and its results, our second experiment kept the same parameters with respect to the incline of the block and the plane and the inertia parameters. However, our spring parameters were changed. Instead, our K constant was increased, meaning that our spring would not propel as much force. This is shown through the graphs on the right, where the yellow shows that the velocity of the spring changes dramatically and it is decreased compared to our first experiment, with the position of the block changing significantly as the block has not been propelled with enough force up the incline.
The main change in experiment 3 is that we've changed the degree to 5 degrees and changed the distance to 0.5 for L2. We have kept K the same as experiment 1 as 1 e to the power 4. When we plot the graphs, we can see that the graphs have a range that is exactly half of the range that we had for experiment 1. In this table, we can see a comparison between all three experiments. When it comes to position response, in experiment 1 there was a large initial oscillation with faster decay. For experiment 2 we had large oscillations with a slower decay, and for experiment 3 we had small oscillations overall. The decay was the same as experiment 1. When it comes to velocity response, experiment 1 had sharp triangular peaks and fast changes. For experiment 2, it was gentler slopes with slower changes, and for experiment 3, it was sharp peaks but smaller magnitude. And for the force response, you can see high narrow impulse peaks for experiment 1. For experiment 2, it was low, broader impulse peaks, and for experiment 3, it was medium impulse peaks that were around exactly half of which we saw for experiment 1. The next two slides show the MATLAB code for this question. We are able to use the MATLAB code to replot the graphs of position, velocity, and force. Furthermore, we are also able to look at a specific position in time for each of the graphs, so we can get a better understanding of how it looks at that specific time.